Same page. I'm reading it. Use the circle shown in the rectangular coordinate system to draw each angle in standard position. I'm going to say use the unit circle. State the quadrant in which the angle lies. When an angle's measure is given in radians, work the exercise without converting to degrees. I'm not going to ask you to do that. I mean, why? If it's easier for me to change from radians into degrees, why wouldn't I do it? Right? So in 44, I have 7 pi over 4. We're asked, and I'm going to ask more than just this. I'm going to ask you to find where the angle has its terminal side. I'm going to ask you to find the reference angle of that given angle. Let's call it alpha.
Between the x-axis, right? The reference angle is
Always between the terminal side and the x-axis. Correct. The acute angle. Good. And I'm going to ask you to find all trig functions. So I'm adding on to this question. So we're given alpha. First, I have to picture it because I don't know where it is. So where does it? Go ahead.
You do pi over 4 times 7. Pi over 4
Yes, I don't need to
is
multiply it. So here it is. I already know that pi over 4 is 45. So it's 7 of 45. 1, 2, 3, 4, 5, 6, 7. There are 8 45s in the whole circle. So there must be 7 till here. Right? 2 of 45, another 2 of 45, 2 more 45. This is 6 and another one. That's the 7th one. Now I'm going to ask you, what is the reference angle?
45.
Yes. So this is the reference angle right here. Reference angle, which is pi over 4. And now I'm going to ask you to find all trig functions for this angle. So I'm going to say, find sine 7 pi over 4. Find cosine 7 pi over 4, and the rest will follow. Now, first question is about sine. I need to remember where is sine positive. First of all, where do we measure sine? That's the first question. On the y-axis. So where is sine positive and where is sine negative?
Positive.
Top and negative bottom. So it will be a negative answer, correct? Okay. So I know that this will be negative sine of the reference angle. But I do know that little chart that starts with 1/2 the square root of 3 over 2, 1/2 the square root of 3 over 2, the square root of 2 over 2, the square root of 2 over 2. So how much is sine pi over 4? Exactly, with minus in front. Very good. Excellent. Now, I do know cosine. Where is cosine measured? Because I need to remember what is its sine. So cosine is measured on the x-axis, which means that this side is positive and this side is negative. So cosine will be positive. So cosine whatever will be cosine of the reference angle. Positive because in this quadrant, cosine is positive. The square root of 2 over 2. Now the rest, I don't have to memorize. If you remember, I said don't waste your time and energy on that. I know tangent of 7 pi over 4. How do I get it?
By sine of cosine.
What is the answer? Careful. We have to take into account the signs. -1, very good. Cotangent of 7 pi over 4.
4 over 7 pi.
-1. So it's 1 over this, right? 1 over tangent. 1 over -1 is -1. So now I want secant, 7 pi over 4. Yes? Say it again. Why is the tangent -1? -5 over +5. These numbers are the same. One is negative. So it's -1. And then cotangent is 1 over this. So 1 over -1 is -1. Okay, what about secant? secant is 1 over cosine, so it's 1 over cosine 7 pi over 4. I have it right here, and I have to flip it. So it's 2 over the square root of 2, and I have to rationalize the square root of 2. This is 2, this is 2. What about cosecant? So it's 1 over sine. So it's the same thing, but it's with negative. Any questions? Yes?
In order to get 7 pi over 4 on the unit circle, you counted 7 dots? Like
I counted in one quadrant there are 2 of pi over 4, 45 and 45. So 1, 2, 3, 4, 5, 6, 7.
Okay.
Because I know that this is 45 degrees. And I know that there are 8 45 degrees in the complete circle. So there are 2 here, 2 here, 2 here, and 2 here. 1, 2, 3, 4, 5, 6, 7. Any questions? Is this okay so far? Okay. Next, I'm still on page 529. I just went ahead. Coterminal angles. So let's look at 58. We are given 415 degrees, and we're asked, I will ask you to find a positive and maybe a negative angle coterminal with 415. I have no idea what 415 is, but I will draw the unit circle. I know that this is 0, and when I get back here, I have 360 degrees. Now, I will subtract 360 degrees from 415, and what do I get? Is it 55? Okay, so then I know that from here I have to go up 55 degrees. Well, this is 30, this is 60, so I'm going to say 55 is here. So this is the angle that I'm looking at, 415 degrees. So 360 plus 55. I'm asked to create or find 2 angles that are coterminal with 415. Start at the same point, end at the same point. That's what coterminal means. So that angle has to start here and has to end here. What will be the first angle that you can think of? Right. What will be a second angle? And I will ask you to find a negative one this time. So this is 360, but I'm going back 55. So it will be indeed negative 105 degrees. I'm sorry. Of course. Any questions about coterminal angles? Why do I need to know coterminal angles? Why would I need to know 55, negative 305, and 415? These are all 3 angles, coterminal angles, right? All 3 start at the same point and end at the same point. Why is it so important to know that these are coterminal angles? So what? Since they start at the same point and they end at the same point, what will they all have in common? Same what? Same sine, same cosine, same tangent, same cotangent, same secant, same cosecant. That's why they are important, because they will have the exact same trig function values. Perfect. Okay, I think we can move on. Yes, Abu?
694, number 11.
Yes, you have a question? Very good. So number 11 on 694. Very good. Let's take a look. Oh, you can give it to me? That's fine. Yes?
Sine x equals square root of 3 over 2.
Very good. We want to solve this equation. Excellent example. Perfect. So first I will draw the unit circle. Then I will ask myself, where is sine measured?
Y-axis.
On the y-axis.
Positive.
Where is sine positive?
-22.
Very good. Now I go back quickly to that little chart, which I will write the moment I get my final exam paper. I will write it in the corner. Exactly. I'll write in the corner is 1/2 the square root of 3 over 2, the square root of 2 over 2, the square root of 2 over 2, the square root of 3 over 2, and 1/2. So I don't forget. So since I'm here, what angle is this? 60 degrees. So remember, so this is 60 degrees, and there is another angle with the terminal side in the second quadrant that has the exact same height here. This is its sine, and this is its sine as well. That's why this angle and this angle will have, although these are not coterminal angles, but they will have the same sine. But coterminal angles will always have the same trig function values. Good. So then I have two options. What is the first of all the reference angle? And it has to be the same. Right. So it's pi over 3 and it's pi over 3 or 60 degrees. So then the equation sine x equals the square root of 3 over 2 has two options. X equals and x equals. And plus 2 pi k because it's sine and the period of sine is 2 pi. So what we have pi over 3 indeed plus 2 pi k. What else we have? Right. Right, because you can go back from pi, you subtract pi over 3. From pi, you subtract pi over 3. Right? Pi minus pi over 3. This is the least common denominator is 3. 3 pi minus pi is 2 pi over 3. Because you know that this is pi. And the terminal side is here. So from pi, you know the reference angle is 30. I'm sorry, pi over 3, which is 60 degrees. So from pi, you go back 60 degrees, and you get this angle of 2 pi over 3. Is this okay? Is this okay?
Yeah.
Perfect. Yes?
So, if we always have to convert it to radians?
No, you don't have to. It's easier for me to write radians. Don't forget your question, just one second. It's easier for me to write radians, but you don't have to. So the solution, or any of these two, you can write as 60 degrees plus 360 times k. See, for some reason it's easier to write this than 60 plus 360k, but it doesn't matter. They are the same. So both are correct. Yes, Kenny?
So we have a question later on the test.
Yes.
To get full credit, and show all that.
You don't have to. But if you make a mistake and I see this, at least I know how you think. How will you write it?
No.
So you have this. So just dictate to me and I'll write it. So then I'll know what you mean. So, and then I'll say yes or no. So you have sine x equals the square root of 3 over 2.
What if I just really know the top of my head?
Say it again.
What if I just know the top of my head?
Okay. And I gave an example last time. And you said, oh, I can't answer.
I'm just wondering, that's all. But
Try. I don't know what to say.
I'll show work, but I'm
Okay.
just saying.
Okay. Well, as long as you show something and you don't make a mistake, you'll get credit. For sure. Okay, on page, next section, page 545. We are beyond this because we already discussed the important information a few minutes ago. So let's say problem 16,
What page are you on?
545. Yes.
Are we gonna be tested on what we studied on Tuesday, the graph and the cosine log?
I'm
cosine?
reviewing everything today.
Okay.
Yes. And the rest I will be reviewing on Saturday from 1 to 3.
Did you forget to post it? I'm sorry, I'm not sure.
It's on there.
It's on there now? Oh, okay.
Okay, so problem 16 on page 545. We are asked to use the given, yes. we're asked to find what a tangent pi over 4 plus cosecant pi over 6 is. So tangent pi over 4 plus cosecant pi over 6. And if you remember, I specifically said, do not waste your time with tangent or cosecant or anything else but sine and cosine. Nothing else. You don't need to memorize. Now, I already know tangent. Why? How come I know tangent? Because I know that tangent pi over 4 is the only one that have sine and cosine the same value. So then I know tangent pi over 4 even without thinking. What will this be? 1. Right? Because it's the only angle that has sine and cosine the same. Okay. Now, this is a little bit more difficult, right? Because first of all, I have to remember what it is. So what is cosecant pi over 6 equal to? Cosecant pi over 6 is the same with 1 over, exactly. But I do remember sine pi over 6 because it's the very first angle in the very first column, first column, first row, or 1/2. So this is 1 over 1/2. When I flip, I get 2. So I come back to my expression and I get 3. Yes?
I'm sorry. So the tangent I know is sine over cosine, but how did you get 1?
Because this is the only angle whose sine and cosine are equal. And when I divide the same number over the same number, I always get 1.
Oh, so you could have wrote it sine of square root of 1 over 4 over cosine over.
So tangent pi over 4 is sine pi over 4 over cosine pi over 4, which is the square root of 2 over 2 over the square root of 2 over 2, which is 1. It's the only angle for which sine and cosine are equal. Okay? Problem 20.
Is then you just add them together?
Yes, we were asked to simplify this expression. We determined tangent pi over 4. We determined right here cosecant of pi over 6, and we add them up, and the simplified form is, or simplified expression is 3. Okay, problem 20. We are given sine theta, which is 6 over 7, and cosine theta, which is the square root of 13 over 7. They're asking us to determine the rest. Again, we're way beyond that from what we did, but let's do that. I'm given sine and cosine, and I'm asked to find tangent, cotangent, secant, cosecant. So, say it again. So cosecant is from here. Very good. I like to represent them in order, but it doesn't matter. Very good. So this is secant is 7 over the square root of 13, and I will have to rationalize. I will not deduct points, but normally we rationalize. 7 the square root of 13 over 13. Now what about tangent and then cotangent? Yes, indeed. And I will rationalize it into 6 the square root of 13 over 13. And cotangent is this reversed, exactly, the square root of 13 over 6. So we determined all the other 4. Okay, a problem like 28 can be on a test. 28 on the final exam, I meant, right? Sine squared pi over 10, I think we did this last time. Cosine squared pi over 10. Exactly. Because this is the first and the most important trig identity. Sine squared alpha plus cosine squared alpha equals 1. So sine squared of an angle plus cosine squared of the same angle is 1.
Is that only for sine and cosine?
It's only for sine squared
Or
plus cosine squared.
no other?
Because of this. So if this is an angle, alpha, this, it's cosine, and this it's sine, and this is 1. And it's a Pythagorean theorem. Sine squared plus cosine squared equals 1. Okay. Of course, problem 42 is like tangent 52.6 degrees. I could never determine this by hand. So make sure that your mode is in degrees, otherwise you're going to get a weird number, weird answer. So yes, my calculator is in degrees. So I have a tangent, and that's 52.6. Close the parenthesis, and you get 1.31 approximately. Okay. Now I would like to look at word problems, because these are the important problems
I'm
here.
sorry, I just have one.
Yes.
So all the ones that have the sine squared, cosine squared the same degree,
Same angle.
or the same
Yes.
angle, they were all, so all these are 1 pretty much, the answer for these? The ones in the book,
Which ones are you looking at?
like 20, 25, well, yeah, 25 through 30.
25 is a product.
Oh, okay, so the ones that have the sine and cosine squared. no.
Squared. So if they have sine squared of an angle plus cosine squared of the same angle, there would be 1.
Okay.
But if it's a product, it's a different situation. So if we have a product, like, we did not discuss this, and I don't think it's part of this course right now because we haven't discussed more identities. But since you asked, I'm gonna explain. Sine of twice an angle is 2 times sine the angle times cosine the angle.
Is this a new identity?
It's a new identity, yes, which we have not discussed. So you're not going to see it on the final exam. But if I have like problem 25, and this is sine 37, and this, oh no, it's cosecant. I'm sorry. I thought you were sine cosine. Okay. Okay, I'm making up a problem now. So cosine 37 degrees, then all I have to do is just say this is sine of 2 times 37 divided by 2. But what they wanted is different. So in 25, it is a product, but it's way easier than this. So sine 37 degrees times cosecant 37 degrees. So they want us to simplify this. So this is sine 37, and I have to remember what cosecant equals to, and I know it's 1 over what? Exactly. Sine 37, whatever number this is, simplified with whatever number that is, and the answer is 1. For some reason, I don't know, my glasses got fogged up, and I thought it was cosine. But no, it was cosecant, which does not require any identity.
I don't know if I should ask this question because you said we're not going to be dealing with anything like if I'm.
But I want you to ask, is it something that you worked on?
It's page 560,
Can you give it to me?
like number 69.
69 on 560. Okay. What does it say?
Secant
Yes.
7 pi over 6.
7 pi over 6. Yes. What are we asked to do? What are we asked? So it's 516.
I'm just, because you said you're just using sine and cosine, so
69.
that's why I was saying that. I don't
69.
even need to ask that.
Find
question.
exact value. Oh yeah. This is very easy. Right. Because so this is cosecant, which is 1 over sine 7 pi over 6. And now I'm going to determine 7 pi over 6 and put it in there and divide. So let's find sine 7 pi over 6. I need the unit circle. It's a very good question. I was going to get to this, but since you asked, that's fine. What is this? Yes, it is 30. So I have 7 times 30. So 1, 2, 3, 1, 2, 3, and 1 more. So this is 7 pi over 6. So there are 3 of those pi over 6 in
Did you
each
flip it?
quadrant. Yes, I just put it in here. That's what it equals to. That's the definition. Cosecant is 1 over sine. So then what is the reference angle? Exactly, pi over 6 or 30. Very good. What is the sine of sine in the third quadrant? Negative. So sine 7 pi over 6 equals negative sine of pi over 6, sine of the reference angle. You're right, because we know that this is 1/2, so this is negative 1/2. So now I will put it here,
There's 2.
negative. So 1 over negative 1/2 equals negative 2. I only said do not sit down and memorize these numbers. All I said, remember sine, cosine for those 3 angles, and then you'd know everything else. I just said don't sit down and memorize this. It would be a waste of time. I didn't say that you cannot have a cosecant of 7 pi over 6. But you will always go back to the simplest possible trig functions, which are sine and cosine. Once you have sine, you're done with cosecant. Is that okay?
Solve sine.
So you solve for sine and then you put it in.
Exactly. Exactly. I specifically said only look at sine and cosine. That's all you need, because the other 4 trig functions depend on both or just one of them. So once you know sine and cosine, you know all the other 4. And I don't want you to sit down and memorize those numbers. The tangent, cotangent, secant, cosecant for 30 degrees. It's useless. For 45 degrees, useless. For 60 degrees, useless. Because it takes you, what? A minute to determine it. Having sine and cosine. That's all I meant. But if you want to memorize them, you can. I didn't, ever. I just need 30 seconds to determine any of the other 4, knowing those 3 numbers. Which numbers? 1/2, the square root of 3 over 2, and the square root of 2 over 2. Now, if you have something like this, which I don't think it's part of this course, sine alpha equals 0.33, then I cannot answer that question. I have to apply the inverse function and put in the calculator. I will never be able to tell you what alpha is. But if you give me sine alpha equals the square root of 3 over 2 like we just had, and if you ask me after that, find, I don't know, cotangent, no problem. Because I know that this is 60 degrees, alpha, and then I know that cosine will be 1/2, and I can determine all the other 4. Okay, very good. So I like to look at a word problem like 74. I think we did 74. Maybe we should do 73. 546. 546. To find the distance across a lake. Did we do 57? I'm sure we did at least one problem here, but I don't remember which one. To find the distance across a lake, a surveyor took the measurements shown in the figure. So 630 yards, and this angle is 40 degrees. And of course, this is a right triangle with a right angle. 546. Use these measurements to determine how far it is across the lake. So we're asked to find the distance BC, around to the nearest yard. So here's the picture. So this is problem 73 on 546. So we have 40 degrees, we have 630 yards, and this is what we're asked to determine. How will you approach this? This is an important problem, way more than the other ones.
Would be tangent of 40 degrees.
Exactly.
Equals A over.
Exactly.
630.
Tangent 40 degrees equals A divided by 630. I think it was 30, yes. Okay, so then what should I do next?
Get your calculator.
True, but before that, yes,
So you
absolutely.
multiply.
Cross multiply. So I have A equals 630 multiplied by tangent 40. Excellent. Of course, I will not be able to do it by hand. So 630 My calculator is still in degrees. Tangent, 40 degrees, and close. So it's about 529. So A, about 529 yards. And yes, this is important.
One of those homework lists
Yes.
that said you it didn't give you the degree. It gave you both the height and the
Which problem is that? I like to look at it. Which one?
48.
48
Yeah.
on 632? Very good. So let's take a look. A building that is 250 high has a shadow 50 feet long. So this is 250 and this is 40 feet. And I'm assuming the sun is right here somewhere. And this is the shadow and this is the building. Find the angle of elevation right here to the nearest tenth of a degree of the sun at this time. Very good. You're right. It should have not been on the homework.
No, I mean,
You were right.
yeah. I mean,
So we're asked to find this angle. So again, what do I write? Very good. Alpha, which is unknown, equals.
250 over 40.
Good. So I'll simplify a little bit, but I have to apply the inverse function. And no, I will not put a problem like this on the final exam. Because there is a concept behind it, which we didn't, it's not part of the course. As you saw, all those sections were skipped. They were not on the syllabus. So let's finish it because I want to finish it. So the second and the inverse function is right here, tangent inverse. And in parentheses, I have 25 divided by 4. And my calculator is in degrees, so I got the answer as being roughly 81 degrees. But no, you're not going to get a problem like this.
We get extra credit for getting it ready.
Yes, yes.
This might be a ridiculous question, but I'm confused when I should know when the calculator should be in radians and when it should be in degrees.
Right. Now, in this particular situation, it didn't matter. But I would have not gotten 81 if that my calculator would have been in radians. I would have gotten some like 1 point something.
Okay.
And if I get something like that, then I realize that that's right. So if I go back and change the mode, very good question actually, and change the mode and redo this thing, look what I get. Because I know that 1 radian is about 60 degrees. And we should remember that. About, it's 57 point da 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 da. But, so when I get something like, of course, nobody knew what I was talking about. So when my calculator was in radians, I got 1.41. If it's in degrees, I get 80. But even if it's in degrees and I get 1 point something, that's what it is. It's 1.4 degrees. So when I punch in, it's a good question. One more time. When I punch in tangent 40 degrees, it has to be in degrees. When I punch in tangent pi over 6, it must be in radians. Otherwise, I get something very weird. Now, when I punch in numbers and I want to get an angle, then I want to know, I have to decide, do I want the angle to be in degrees as the answer? Then I make sure it's in degrees. Do I want the angle to be presented in radians? Then I put it in radians. Now I can change 1.41 into degrees. That's not going to be a problem if I want to, or vice versa. So if I want to change 80.9 into radians, I can. So that will be the conversion.
Is there a way to do that with your calculator?
Yes, you have to do it with a calculator because if you remember, pi equals 180 degrees. So if I have 81 degrees, I have to find what 1 degree is, which is pi over 180. And I guarantee that roughly 81, it's not exactly, right? 81 multiplied by pi over 180 will be 1.41,
Oh, yeah.
right? So this is what we got. So if you, of course, I'm not going to get exactly this because I rounded up. So 81 multiplied by pi and divided by 180. When I hit enter, I have to get roughly 1.41. So I can go back anytime between 80.9 to 1.41 or for 1.41 back to 80.9. Is that okay? Perfect.
I'm just
Yes.
wondering, on Saturday,
Yes.
are we gonna go over trig or are we gonna go
If you
over-
have questions on trig, I will go over trig. If
And
otherwise,
also-
my plan is to review anything else. But if you have questions, did I ever say no? I'm not going to answer this one.
No, we always answer.
No.
questions.
So
But
that's.
I was wondering if you have maybe a paper
I will post a list of questions that I would like you to look at.
that will cover the whole course.
The whole course.
So if we do it, we're gonna get an A. Get everything right.
You already have 200%. How much more do you want? Okay, you have 250%.
Are you gonna take the final?
Okay, let's use the time efficiently. Let's move on. There's nothing else in 5.2. Let's look at 5.3 now.
It's impossible. It's not good. Credit on 3 tests.
Okay, I'm looking at problems from 19 through 25. We did almost all of them. Let's do one more. Let's say 11. Secant pi. And if you remember, I said, do not bother with secant because we know what it equals to. And what does it equal to? 1 over cosine pi. But this I know, and I have to know. Where is pi? Well, it's right here. Where is cosine measured?
On the x-axis.
Right, so what is the value of cosine here?
-1.
Right, so then you have 1 over -1, and the answer is -1. Okay,
What page was that?
that was 560. 11 on 560. Now I would like to look at the next set. Please choose. This is a little bit more sophisticated. Now 17 through 21 is a little bit more sophisticated. It needs a little bit more work. So let's choose one. You choose. Okay, I will. 20. So tangent theta is less than 0, and sine theta is less than 0. Oh no, they're only, I'm sorry, I thought they were asking us to do something with that. But no, they only want us to identify the quadrant. In the next problem, they want us to do everything else. So I need to identify just the quadrant. Tangent is negative in which quadrants? And the answer is where sine and cosine have opposite signs. Exactly. So tangent is negative here and here, indeed. Where sine and cosine have opposite signs. Sine and cosine are positive here, so tangent will be positive. Sine and cosine are both negative here, so tangent will be positive. So that's why tangent is negative in the second and the fourth. Now, where is sine negative? Down, exactly. Exactly. So now I identify theta. Where is theta? Where both conditions are fulfilled. Yes, in the fourth quadrant. Very good. Now the next one is, I would say, a little bit more sophisticated. So please choose. Let's say 28, unless you want to choose. 28. On page 560. We are given cos sine theta equals 1/3, which nobody knows what it is. And we are told that theta is between 270 degrees and 360 degrees. What does that mean?
in the fourth quadrant.
Exactly, that's all it means. It means that it's in the fourth quadrant. Excellent. So, is cosine positive in the fourth quadrant?
Yeah.
Okay, of course. What about sine? It will be negative. How do I determine sine?
Sine squared plus cosine squared.
Equals 1. Excellent. That's the formula. So this has to wait for a moment. So I know that sine squared theta plus cosine squared theta equals 1. And I'm trying to solve this equation for sine squared. What should I do? Subtract. Very good. So sine squared equals 1 minus cosine squared theta. What should I do to both sides to get sine by itself? Take the square root. So when I take the square root, I have to write plus or minus. However, in the fourth quadrant, it cannot be plus or minus. We already established
It's negative.
it's only negative. So now what I have to do is replace cosine by
1/3.
1/3 and square it. Very good. So I have minus outside, the square root of 1 minus 1 over 9. So 9 minus 1 is 8. So minus the square root of 8 over the square root of 9. I should take 2 out because it's 4 times 2. Negative 2, the square root of 2 over 3. And that's my answer. Okay, now I have sine and cosine. The whole thing is done, almost, right? I just have to write the other 4. So how do I write tangent?
Sine over cosine.
This over this, so I have to flip, right? Negative. Don't ever forget the signs. The signs are very important. Very good. And now what about cotangent? It must be 1 over this. So negative 1 over 2, the square root of 2, and I will rationalize with the square root of 2 and the square root of 2. So negative the square root of 2, this is 2 times 2 is 4.
So we don't have to rationalize it?
We normally have to rationalize. If that's your only mistake, I'll close an eye. But normally we have to rationalize the denominators. Yes, go ahead.
The tangent, I know it's sine over cosine, but
Okay. So negative 2 the square root of 2 over 3, everything divided by 1 over 3 is negative 2 the square root of 2 over 3 times 3 over 1.
I was
Yeah, you have to flip the denominator. You have to change the...
no, I was looking at cosine over sine.
Oh, okay. No problem. Okay, so we have sine, we have cosine, we have tangent, we have cotangent. Now we have to find secant theta and cosecant theta. So how much is secant? 1 over
Cosine.
1 over cosine. So 1 over cosine. And cosine is 1/3. So how much is secant? Very good. And now cosecant is 1 over sine. And this is sine. So it's negative 3 over 2 the square root of 2. And I will rationalize with the square root of 2 over the square root of 2. Negative 3 the square root of 2. This is 2 times 2, which is 4. So this is a problem that you will see on the final exam, which requires a little bit more time, as you see.
I just have a question.
Sure, yes.
How you got up above all the way number 11. How you got so secant secant pi. You change it into what it would be equivalent as cosine,
Right, so secant is 1 over pi. Secant pi is 1 over cosine pi.
and then how did you get 1 over negative?
I have to determine cosine pi. Cosine is measured on the x-axis. Pi is right here, so cosine is negative 1. Remember in addition to that little chart, I have to remember these points. So this point is 1, 0. Cosine is 1, sine is 0. This point is 0, 1. Cosine is 0, sine is 1. This point is negative 1, 0. Cosine is negative 1, sine is 0. Because cosine is always the first. This point is 0, negative 1. So cosine is 0, sine is negative 1. So these I have to remember from the, I would say they're not corners, but you know what I mean. The yes, those have to be
It's only one point, but not actually in the quadrant, there's the point.
right. Yes. However, those points do not belong to any quadrant. So 90 degrees does not belong to quadrant 1 or quadrant 2. 90 degrees is completely separate. That's why you see here not the equal symbol, not the equal symbol. So a quadrant does not include the endpoints. So the quadrant here is between 0 and 90, not 0, not 90. Okay, very good. So now we're asked to find the reference angle. Well, we've done that, but let's do another. Let's say 43. I have 5 pi over 6. We are given an angle. We're asked to find the reference angle. Well, I have no idea what this is. I'm looking at the unit circle. What angle is this? 30. So I have 5 of those. 1, 2, 3. 1, 2. So this must be the angle that I'm talking about. So what is the reference angle? That's all we're asked to find. Exactly, or pi over 6. Very good. One more type here. Use reference angles to find the exact value of each expression. An important type of problem. So please choose from 61 through 75. 61 through 75. Okay, 1, 2, 3. I'm going to say 40. I'm sorry. Did you choose?
Say 61 through
61 through 75. 64. Very good. Where are you? 64. Okay, very good. Secant, 240 degrees. They're asking us to find this function value. Excellent. Have no idea where 240 is till I look at the unit circle. Okay, so secant 240, I know that this is 180. So between 180 and 240, I still have to go how much more?
60.
60. So right here. So this angle is 240 degrees. My professor said don't bother with secant. I'm not going to bother with secant. So what does this equal to? 1 over cosine 240. Perfect. And now I have to determine the reference angle. What is the reference angle? 60 degrees. But now I have to think about the sign of cosine in the third quadrant. Negative. So then I continue by writing 1 over negative cosine 60. Now I have to go back to my little chart. 60 is at the bottom, is the third angle. So cosine is 1/2. Very good. So 1 over negative 1/2, so this must be negative 2. Okay, one more time, let's go through this, because this is important. Secant 240 degrees. I know nothing about secant, only that the secant is 1 over cosine 240. I picture the angle. I see that it ends in the third quadrant. I know that cosine has to be negative. I find the reference angle. So cosine 240 must equal the opposite of cosine 60, which is the reference angle. I know that cosine 60 is 1/2, multiply by negative 1, and then I flip.
And is it negative because cosine is
It's negative, yes. Cosine is measured on the x-axis. Cosine is positive here and negative here. Okay, we're done with 5.3. 5.4 was not recommended at all. We were asked to skip. When it comes to the graphs, I'm going to ask only one question. It will be either sine, or cosine or tangent. So let's say I ask graph sine, so f of x, sine x plus pi over 2. Okay, I will graph sine. I know how to graph sine. Pi over 2, pi, 3 pi over 2, and 2 pi. And I know that this is the graph. That's all I'm asking you to do. And then use a transformation and tell me, where does this graph go? That's all I care about. It goes left how much? Exactly. So this point moves here, this point moves here, this point moves here, this point moves here, and this point moves here. That's all I want. So this is this function. This is only sine x. That's all I want you to present. It could be the same thing with cosine or tangent. Would you like me to show any other? Which one? Any preference? Let's say f of x equals cosine x minus pi over 4. We must remember these three graphs. So this is the graph for cosine. You can refresh your memory by punching in the graphing calculator, but you have to be careful. You have to be careful about the x-axis, the units on the x-axis and the units on the y-axis. And if it has pi over 4, you have to be in radians. So how will I graph this function? Where does it go?
Go to the right 1.
To the right? Yes, so this is pi over 2. So this point only moves halfway. This point moves halfway. This point moves halfway, and this point moves halfway, and this point moves halfway. So here's the graph. This is the graph of cosine x minus pi over 4. If you remember these three graphs, that's all I need.
So you just have to memorize what they look like?
Yes. You only have three graphs. So let's also look at f of x equals tangent, let's say x plus pi. Here's the graph of tangent. You have to remember that it's undefined because it's a ratio where cosine is 0. So this is negative pi over 2, and this is pi over 2. So here's the graph. Easy to remember because it's similar to x cubed, but x cubed does not have asymptotes though. So maybe I shouldn't refer back to that. I don't want you to think that it has asymptotes. So now I'm asked to move this graph where? To the left, how much? Right. So this is pi, right? This is indeed, that's true. But I'm moving just one period. Yes, that's true. So if I move this pi, it will go here because this is pi over 2 plus pi over 2, which is pi. So this point moves pi to the left. This point moves pi to the left. This point moves pi to the left. So this is it. So this one moved pi to the left. This point, pi to the left. This point, pi to the left. But it's the same graph because if I graph all of them, will be part of both.
So, so if it was 2 pi, it would be way over.
Yes.
And there
Yes.
would be nothing in the middle.
Exactly. Well,
There's still, because it repeats.
it repeats itself indefinitely, so there will be. But I will only want you to move one.
Okay.
Yes. So this is tangent x, and this is tangent x plus pi. Very good. we look at as you see 5.7 is not even okay. 5.8 you had a question on 5.8 and I think it's the same thing. We did not do 6.1 and 6.2, they're not part of the course. 6.3 is not part of the course. 6.4 is not part of the course. Yes, 6.5. Okay, so let's look at a couple more examples from 6.5. We exhausted everything that was, oh, maybe not. Let's say 15, cosine x equals negative 1/2. So 15 on page 694. And we are given cosine x equals negative 1/2.
What number?
15. So we're asked to solve this equation. Okay. Go back to the unit circle. Cosine is measured on the x-axis. Where is cosine negative?
On the left.
On the left side. Very good. So it's negative here and here. Good. Now, which angle has cosine not negative 1/2? 60 degrees. Very good. So then I need a reference angle of 60 degrees. So again, the reference angle is 60 degrees. And there is another one here with the same cosine. This piece, this is that cosine, bless you. So this is the second one. What is the reference angle here? I know it's silly. Of course. So can anyone give us the red angle and then the purple angle? So these are the solutions. X equals, and yes, plus 360k plus 360k.
120 degrees.
Yes. So from 180 I go backwards 60. And from 180 I go forward 60. Okay? Yes? Any questions? Any questions? Do we need another trig equation? Okay, very good. Please choose. I'm looking at 19. Let's do 19. 19 we have 2. Cosine x plus the square root of 3 equals 0. And we have to review 2 more sections, 7.1 and 7.2. Law of sines and law of cosines, and that's it. Okay, so then, what should I do first?
Move over square.
Yes, 2 cosine x equals negative the square root of 3. Now,
5 by 2.
cosine x equals negative the square root of 3 over 2. Okay, so it's pretty similar.
3 angles.
Go back to the unit circle. Which quadrants?
2 and 3.
Exactly. And the reference angle indeed is 30 degrees. So one angle is the red angle coming up, and the other one the purple. What is the reference angle for both, of course? 30 degrees. So then we have 2 solutions. First solution. This is 180. I'm going backwards 30, and 180 going forward 30. So 150 plus
360.
360k and 210 plus 360k.
So how come it's not in radians, how it's in degrees?
Oh, because the first person who said 30 degrees, then I kept it in, but in that case, if you want to say that this is pi over 6, then you will have pi minus pi over 6, which is 5 pi over 6, plus 2 pi k, and pi plus pi over 6, which is 7 pi over 6, plus 2 pi k. All of them are the same.
So it doesn't matter on
No.
the test we.
No.
And then you have to find 2 solutions because cosine is negative 2
Not necessarily. For example, if, very good question, not necessarily. So here is an example in which you will not find two solutions. So let's say cosine x equals -1. This has only one, infinitely many, but only one, because it's at that end point. So that would be x equals,
or it.
exactly, 180 plus 360k. And this will not have two different options. Very good question. Okay, I would like to review the law of sines and law of cosines with a word problem.
Can you also apply to that?
Say it again.
Can you also apply to that for simple?
Oh, okay, if you want to write it as pi, it's be pi plus 2 pi k. It's up to you. I will not indicate. If you want it in degrees, write it in degrees. If you want it in radians, you can write it in radians. Okay, let's look at problem 14 on 710. You will not have other problems than the ones we discussed today. Okay, this is everything. Okay, so 14 on 710. We are given angle B, which is 5 degrees, angle C, 125 degrees, and lowercase b, 200. We're asked to solve this triangle, which means present all angles, present all sides. What do I have to do first? I can't start before I do that. What? Say it again. Draw a triangle, exactly. I have to draw a triangle. This is not a right triangle. So I have to label the vertices. Why is this so important? Because I know that the opposite side of angle A is A. The opposite side of angle B is B, which is given 200. The opposite side of angle C is C, which is not given. So I have angle B, which is 5 degrees, and I have angle C, which is 125 degrees.
So you would do sine of 5 degrees.
Sine A, we always start with A, but it's not a mistake if you don't. But I always start with A. Sine A over A equals sine 5 over 200 equals sine 125 over C. Which proportion will give me what I'm looking for? The last two, yes. Because only in these two I have only one unknown. Here I have two unknowns. I couldn't use this. So I have to use this. What do I do with the proportion always? Right. So I have C sine 5 equals 200 times sine 125. How do I find C?
That's
200 times sine 125 over sine 5. So I have to punch it in the calculator. So,
I have a question.
yes, please.
Couldn't you have found the degrees of angle A
Yes,
just by doing like 180?
Yes.
Yeah, okay.
yes. If you want to go that, you can, and you put it in here. That's fine. So you can say that A is 180 degrees minus 5 minus 125. So that's minus 130. So that's 50 degrees. So A equals 50 degrees. So then, yes, if you replace this by 50, you could have used that. Absolutely. So let's determine C. Lowercase c I meant. What we have there, parentheses, 200. Although, since you have only one, we have only one factor in the denominator, it would work without it, but just to be on the safe side. I'm going to look at the mode. It's in radians. I have to change it into degrees. So I have 200. Come on.
Double.
Okay. So 200 and then sine 125, close the parenthesis, and divide by sine 5. So I got 1, 200, it was sine 125 divided by sine 5. Okay, it looks a little big. Okay, so lowercase c is 1880 roughly. So the only thing that I need to determine is A. So I have uppercase A, which is 50. I don't have lowercase a, and I have C already. So now I can use this. And I will write sine 50 degrees over lowercase a equals sine 5 degrees over 200. And yes, I will cross multiply. So 200 times sine 50 equals A times sine 5 degrees, and then I get A, 200 times sine 50 over sine 5.
Where did you get 50?
The sum of angles in any triangle is 180. So from 180 I subtract angle B, which is 5 degrees, and I subtract angle 125, which is C, and I got 50.
So we could have done that.
Yes. So now I determine A, put in the calculator. So 200 times sine 50 divided by sine 5. So 1758 roughly. And we have 3 minutes left. I'd like to look at a problem from law of cosine. Let's say problem 10 on 719, or maybe a word problem. That's better. Let's say, I think we did 42. Let's do 41 on page 720. Find the distance across the lake from A to C to the nearest yard using the measurements shown in the figure. I think we did not do this one. So here's 80 degrees, maybe we did. 140, 160, we're asked to determine x. Okay, any suggestions? Yes. X squared equals 140 squared plus 160 squared, but minus now 2 multiplied by, exactly, multiplied by 160, multiplied by, that's why it's called cosine. Cosine 80 degrees. And don't forget to take the square root. So again, I have to put everything in the graphing calculator. So I have 140 squared plus 160 squared minus 2 times 140 times 160 times cosine, make sure it's in degrees. I did change it, didn't I? Good. So I get a number, but then I have to take the square root from this number. So second and the square root and the previous answer. Or you could have put it from the beginning. So we get 193 approximately. Whatever that was, I think it was yards. Any questions? Yes, Kenny?
What's the easiest way for you to find out which law you apply?
Very good question. I would say this. When no angles are given, I only have one possibility, law of cosines. Because remember, sine over A, sine B over B, sine C over C, if I don't have anything at the top, I cannot solve it for anything. So, but you're not gonna have this situation here because we're not supposed to know how to apply the inverse function to both sides in this course. So I cannot show you the other option, I mean, when all three sides are given, because we can determine angles. We have to wait till 142 to determine angles. That's silly, but yeah, that's what it is. But only when you will just think of the law of cosines when you're given only sides. Yeah.
Uh,
Very good question. Yes, Abu?